right? Right, so we are online. Few of the people are there. Kinda, Sanka, Indika. Shall we put a message to the group so the people maybe can join, because maybe they are waiting from the 8:30. Yeah. Right, hands up those who at least went through the questions at least. I asked you to go through, huh? Good, good. So you have a bit of a knowledge, right? It will be easier for me to finish it, and I'll be giving some, I'll be doing some extra questions that we are doing for the 2025 batch now, because they are doing the full papers these days. So there were some good area volume questions. I want to have you the feeling that what level of question will come to the A levels. I have given, not yet. I'll be giving you the past paper classification. I have given it to the 2026 people. So you can check when you have the past paper classification, how would be the past paper questions or the proper A level questions, right? Now I'll be giving much more difficult questions than those. And I want to discuss few of the questions that I am giving to 2025 people who are recently will be facing the exams on November, right? And those questions are a bit difficult, and if you be able to do that sort of a question, you are safe for these 3 lessons in your A levels exam, the proper A levels exam, right? If you can do those questions, because those are a little hard than the actual A level questions, right? Okay, so shall we start? Yes, right. So what is the smallest measurement that can be obtained? Now I'll be discussing a bit of the theories as well in the middle. We will have some notes, and you'll all have to have some either book or rough papers or something to have the notes. Maybe sometimes they are discussing the things, you may be missing things that you don't remember. Then you put a note that I have to go through this part back again, read this again, do the calculations on this again. If there's specific point, something new, take a note, right? Be actively participating, right? I don't write everything on the tutor. Have a separate note because it will be ugly, right? Come to the first question. What is the smallest measurement that can be obtained using a metered ruler? You already know it. What is the smallest measure that can measure using a metered ruler? Would be 1 millimeter, right? So the Gascoigne and some other scientists, they wanted to go further. They wanted to measure smaller values, right? So because of that, they researched on finding instruments to measure smaller values. What were the instruments? Vernier caliper, micrometer, screw gauge, and sort of instrument. They can measure smaller, real small values, right? Right. So it's how much? 1 millimeter. Answer is 3. If you have answered it correct, put a tick. Right. The diagram shows an instance of measuring the length of a rod AB using the centimeter scale, right? What is the length of the AB? Tell me what is the length of the AB now? This is a centimeter millimeter scale, isn't it? So the lines are aligned and the length should be then. This is 1 centimeter, 1.1, 1.2, 1.3, 1.4. So it's 1.4 centimeters. That is easy. 1.4 centimeters. Right. Third question. As shown in the figure below, when NA is placed below the 0 centimeter mark on the scale, NB is approximately midway between 1.4 centimeters and 1.5 centimeter marks. Since the smallest measurement that can be measured in centimeter scale is 1 millimeter, the reading corresponding to the BN should be 1 centimeter or 1.5 centimeter. What is the maximum possible error in this measurement? What is the maximum possible error that it can occur in a centimeter millimeter scale? 1 millimeter. Any other answers? Huh? 0.5 millimeters, another answer. Any other answers? What could be the highest error that it could happen? So how do you take a measurement when you are like given a centimeter millimeter scale and the measurement comes in between two of the millimeter lines, right? How do you take, like, if whether it is 14 millimeters or 15 millimeters, how do you decide it? Now this is the line, right? This is millimeter values, and the object lies somewhere here, right? Now this is 1 point, or else it's 14 millimeters line. This is 15 millimeters line. Which would you take, 14 or 15? You would take 15. Why? It's more, close to the 15 millimeter line. We consider it is more close to the 15 millimeter line if it passes the middle of the two of the lines, isn't it? Aren't we? We consider it is 15 if the object passes the midline of two of the 14 and 15 lines, isn't it? If it is before 15 and 14 lines, we would consider it 14, isn't it? So the mid decides whether it's 14 or 15. Do you understand that? The mid decides whether it is 15 or 14. So the mid is how much? 0.5, right? So the error that it could occur, the minimum error that it could occur is the mid of the two of the lines in this case. In this case, it's the mid of the two of the lines, which is 0.5, right? So what is the maximum possible error in this measurement? The maximum possible error, not the minimum. Maximum possible error that it can happen is 0.5, isn't it? Do you all understand it? Yeah. The maximum it could occur is 0.5. Usually it's less than 0.5, right? Right. When a measurement is called x and its error is delta x, fractional error delta x over x. Now we discussed about the fractional error. Two of the formulas are there for the fractional error. What are the two of the formula? One is error over measurement. Usually the formula for the fractional error is what? Error over measurement, right? Right? Usually the fractional error is error over measurement. Remember these things, huh? Usually the fractional error is error over measurement, right? If any errors aren't given, remember this. If any errors aren't given, instead of error, you can take what? The least count, right? Instead of error, you can take the least count. If any of the errors aren't given, instead of the error, you can take the least count, LC. Right? Remember these things, huh? So the fractional error has two equations. One is error over measurement. This is the usual common formula. If error isn't given, instead of error, you have to put least count, right? Remember those. If you want to have the notes, have a quick note. Huh? Finish? Nice. Right. So it says the rod is 20 centimeters and they are asking for the percentage error. For the percentage error, you have to multiply the fractional error by 100, isn't it? multiply the fractional error by 100, you get the percentage error. It says the approximate error in length measurement is 1 millimeter. So which should be the answer? Huh? What is the answer? First, second, third? First one. Why first one? The error and the measurement both should be in same units. That is one thing, right? Now these are the things that you do wrong in the papers. What? You take the error in millimeters and put the measurement in centimeters. Is that correct? No, you can't put it that way, right? Have to be in the same units, right? The other thing, it has to be multiplied by 100 to make it a percentage error. So the answer is first, isn't it? The answer should be first one. Right. Fifth question. Taking the maximum error of 1 millimeter in centimeter scale, which of the following measurement can cause the maximum percentage error? Now tell me, measurement and the error, right? Comparing measurement and the error, when the error is increasing, or instead of error we are taking the least count as we discussed, right? We are taking the least count. When the least count is increasing, right? Least count is increasing. What happens to the fractional error? When the least count increases, the fractional error also increases, right? According to the formula, isn't it? According to the formula, when the error or the least count increases, that means this whole thing increases, which means the error is also increasing. And what happens when the measurement is increasing? The whole thing decreases, isn't it? Because it's a division. The whole thing decreases, and that is equal to the fractional error. That means the fractional error is also decreasing. That means measurement increasing, fractional error decreasing. Yes? Hari. Now the question is asking for what? If the percentage error of a measurement, taking the maximum error 1 millimeter in centimeter scale, which of the following measurement can cause the maximum percentage error? They are asking which of the following measurement can cause the maximum percentage error. That means the percentage error is increasing, isn't it? So percentage error to increase, what should happen to the measurement? Percentage error to increase, the measurement should decrease, isn't it? The measurement should decrease. So for the maximum percentage error, the measurement should be the highest or the lowest? Should be the lowest. So take the lowest value out of the values given, rather than calculating it. If you are going to calculate putting all the value to the percentage error, it will take a long time. Rather than that, come to the logic, what? Lower the measurement, greater the error, right? So you take the lowest measurement. What is the lowest measurement here? 10 centimeters. So the answer is 5, right? Hands up those who got the answer correct there. Good. Nice. Do you understand that? Lower the measurement, greater the error. So you select the, the lowest measurement, right? Take notes if you don't know or new with the theory. Right, sixth question. If the percentage error of a measurement exceeds 100%, the measurement is considered inaccurate, right? That is also correct. If the percentage error is more than 1%, the measurement is called inaccurate. It's not correct. Thus, centimeter scale is not suitable for obtaining which of the following measurements, right? So now back again, it's the same sort of a question. So for a percentage error to be maximum, or let's say more than 1%, we don't know, You have to calculate to see if it is more than 1% or not. But without calculating if it is 1% or not, applying the values, what can you do? You can consider what? For a maximum percentage error, the measurement should be maximum percentage error measurement should be the measurement comes under the so it should be decrease. So the lowest measurement gives the maximum percentage error. So you select the lowest. That is easy, right? So you again select the lowest. Which is the lowest? 5 centimeters. We don't know if this is more than 1% or not, but this should be the most correct answer out of 4 because it's the lowest measurement, right? You don't have to calculate all the time. That is what I am telling. You don't have to calculate all the time. Sometimes you have to use your brain, so you can get into the answer quite easy, right? Come to the 7th question. Suitable instruments for measuring small size measurements less than 2 centimeter in length. Right? Suitable instruments for measuring small size measurement less than 2 centimeter in length. What would you use? So if it is less than 2 centimeter, what should be the minimum least count? That gives a, you have to check if it is less than 1% or not, right? So 2 centimeter you are measuring, and if it to be 1%, how much should be the least count, right? So you are measuring 2 centimeters, right? Multiplied by 100, it should be equal to 0.1%. What should be the least count? How do you measure it? 100 to 100 cancels out, and that will be 0.2 divided by 100. So x should be equal to, multiplied by 2, that will be 0.1 into 2 divided by 100, that is 0.002, isn't it? 002 centimeters. In millimeters, that is 0.02 millimeters, isn't it? So it's a very small value. So which of the following instruments give 0.02 of a measurement? 0.02, Which one? Does the centimeter scale give that 0.02? No. Vernier caliper? No. It usually gives 0.1, right? If someone asks what is the least count of a vernier, the common least count given in the syllabus is 0.1. So that is you have to consider. That is 0.1. So can you measure using the vernier caliper? No. Metering, that is, let's say a meter ruler, you can't. Micrometer scale is somewhat can, right? Is somewhat can. Usually it's 0.01. So less than 0.02. So you can only use what? D only, isn't it? D only. It's D only. Hands up those who understood it. It should be D only. So anyone got the correct answer? You got the correct answer. Nice, good. You selected D only. Coming with the conclusion, doing all the calculations and all. How did you do? Okay. Someone whispered to your ears. Someone whispered to your ears. Just came through the answer. Okay. Doesn't matter. Anyways, you got the answer. Right? So try to be lucky at the A-levels exam. You know, some people are there, like there was one student in 2024. He was like not very clever guy. Because I know when I'm speaking to him. And when he's answering the MCQs, he usually gets more than 35. Yeah, all the time, every time. Yes. Now that's something lucky. I don't know how that happens. He usually gets more than 35, and I don't know. He's not that of a clever guy. Black magic or something. Yeah, he's doing something here. Right. Right. So come to the next one. What is the appropriate equipment? All right, we discussed it, right? 8th question. The main scale of a vernier instrument has division of 1 millimeter. That means like its one division is 1 millimeter. 9 such segments coincide with 10 vernier segments. What is the least count of this device? Now I'm gonna teach you one of the easy ways and the usual technique. So how do you find the least count? What is the equation there? Huh? What is the equation? For the least count equals what? What is least count equals to? 1 MSD minus 1 VSD, isn't it? That is 1 MSD minus 1 main scale division value minus 1 vernier scale division values. Main scale division value එකකින් vernier scale division value එක deduct කරාම you get the least count. Yes, right. So you are given the MSD, that was 1 millimeter, isn't it? That was 1 millimeter. That is 1 millimeter minus 1 VSD, like the VSD isn't given. VSD means vernier scale division value, the division value of a one vernier line. So it isn't given directly, but it has given like 9 of the millimeters are coinciding with how many vernier scale divisions? Okay. 10 vernier scale divisions, isn't it? So what is equal to 1 VSD? What is equal to 1 VSD? That is a separate formula. 1 VSD is equal to number of main scale divisions coincide with number of vernier scale divisions, right? So we usually write main scale divisions over vernier scale divisions that are coinciding, align වෙන ගාන. මේකේ how many main scale divisions are given? 9. That is coinciding with 10. So 9 over 10, isn't it? So to here you can put 9 millimeter over 10. That will be 1 minus 0.9. So the least count will be 0.1 millimeters. Now this is the usual way. This is how you answer it if the question comes to a structured essay. Don't worry, these won't come to the essays. Like the measurements unit won't come to the essays. It will be, you will feel like it will be easy if it comes to the essays, because the essay parts are other lesson parts are much more harder than this. This is one of the easy ones. Not saying like very easy, but one of the easy ones, right? So this won't come to the essays, but it will come to the structured essays, right? It will come to the structured essays. So if it comes to the structured essay, this is how you answer it, right? Because the marks are given to the breakdown for each and every, the steps that you go through. But since this is an MCQ, there's one easy way of doing it, right? I'm going to teach you the easy way. So if this is a MCQ and you are asked to find the least count, this is how you find it, right? So let's say you are given you are given the division value of the main scale and number of vernier scale divisions that are coinciding. Is it given in here? Division value of a main scale. Was it given? Yeah, given, bro, it was given. How much? 1 millimeter. Yes, focus, right? that is 1 millimeter, and number of vernier scale lines coinciding. Is it given? It was given. How many lines are coinciding? How many vernier lines are coinciding? That is 10, right? So the easiest way to take the least count is that what? LC equals 1 MSD divided by VSD, right? So 1 MSD is what? 1 millimeter. Number of VSDs are 10. Get it? So how much is it? 0.1 millimeter. This is for each and every all the but you can't use this for the structured essay, right? This is a cheating sort of a good cheating, right? This can only be used for the MCQs. You can't use it for the structured essay or anything, right? So now tell me, let's say 19 lines of 0.5 values are coinciding with 20 vernier scale lines. 19 lines of 0.5 divisions in the main scale are coinciding with 20 lines. How much would be the least count? Huh? 20 in vernier, yes. How do you measure it? Now the main scale division value is 0.5 and 19 of them are coincided with 20 vernier scale lines. How do you find the least count? How do you find the least count? How do you find the least count? Now try to find it by yourself. Do some calculations. Huh? What is the answer? 0.04. Divided it by
20.
Right. That is 0.5 divided by 20, right? Right. Yeah, 0.25, correct. What would be the answer? 0. How much? 0.025, right? 0.025. That is when you use the simplest way, but dividing one division of a value by number of vernier scale lines that are coinciding, that is 0.5 divided by 20. 0.5 divided by 20, that is 0.025, isn't it? So if I go the long way using this one, it will be a bit difficult. That's what I am going to show you. So what will be the least count now? LC equals 1 MSD minus 1 MSD minus 1 MSD minus 1 VSD, isn't it? So the 1 MSD is given in here what? 0.5, right? It is given 0.5 millimeters. And 1 VSD isn't given, but it says 19 lines are coinciding with 20. So how do you find the 1 VSD now? 19 over 20, is it? No. Because 19 over 20 we are taking when the division sign 1 millimeter values. Now the division sign 0.5 millimeter values. When the division sign 0.5 millimeter values, you have to take 0.5 millimeter of 19 values. That means 0.5 into 19, right? That is how you take, right? So 1 VSD you are taking 0.5 into 19 divide by 20. Get it? 0.5 into 19 divide by 20. Remember this, huh? If you are given 0.5 millimeter of division values in the main scale, what you do is you multiply 0.5 by number of lines that are aligned and divided by the number of lines aligned in the vernier scale. Right? මේ වගේ questions එනවා. එතකොට ඔයා 0.5 වලින් දීලා තිබ්බොතින් 0.5 times divisions ටික ගන්න ඕනේ. ඒක divide කරන්න ඕන coincide වෙන divisions ගන්න. right? මේක note එකක් දාගන්න. take a note මේ questions තියෙනවා මේ වගේ. අපි will take a note on this. You don't have to. Right? 0.5 වලින් දීලා තිබ්බොතින් division එකක value එක මේක අනිවාර්යෙන් multiply කරලා තමයි divide කරන්න ඕන. හරි. මේ questions ඇවිල්ලා නැහැ but you have to know. right? තාම ඇවිල්ලා නැහැ but it's a good thing to know. හරි එන්න පුළුවන් කොයි වෙලාවක හරි දායිනේ. දැන් මොතින් 0.5 වලින් multiply කරා divided by the number of lines that are coinciding. right? Huh? You already have this tip, no?
No, I don't have this.
Last one inside that. අපි ඇතුලෙන් ආ චුට්ටක්. right? So how much would be the answer? Now if I multiply this, now easy, like better if you multiply the whole thing by 2 and divide by 2. What happens now? So you can convert this decimal into a number, right? 0.15 multiplied by 2 will be 1. So it's 19 divided by 40. This will be easier. How much would it be? 19 divided by 14, how much is it? How much is it? 19 divided by 40. 0.475. 475. So you have to deduct 0.475 by 0.5. That will be 0.025 millimeters. Now this is the long way of solving it, right? Long way of solving it. And the easy way is what? Yeah, you divide 0.5 by 20. That is 0.025. But you can't use this in the structured disease. That's the thing, right? You can't use this in the structured disease. You can only use it in the MCQs, right? MCQs will make avula nahi. But in the structured disease, make a follow karanna wenna. Otherwise you will only have 1 mark for the final answer. That's all. මෙතන marks 6ක් විතර තියෙනවා. steps වලට. right? Hands up those who understood it. You have to multiply it by 0.5 to get the value. Yeah. Then මීට වඩා අමාරු එකක් තමයි මම පේපර් එකේ දෙන්නේ. මෙන්න මේවත් කන්සිඩර් කළා. එකක් දෙනවා. එක ප්‍රශ්නයක් දෙනවා. චුට්ටි එකක්. හරි. ඒක පොඩ්ඩක් හිතන්න වෙන මේ ඔක්කොම හිතලා හදන්න එක. Bro, I'm gonna give a gift for whoever the persons who will answer it. Yeah, we're gonna miss the gift. Right. Right, come to this one. The smallest measurement of a vernier instrument is 0.1 millimeters, if the length of a main scale segment is 1 millimeter, what is the length of vernier scale segment? They are asking the length of vernier scale segment. Which equation should you put here? I'll try to remember. Which equation should you put here? Smallest measurement is given, that is 0.1, and the length of a main scale is 1 millimeter. They are asking for the length of a vernier scale segment or a division. What is the equation should you put there? Or just you can mentally tell it, tell the answer. What is the answer there? Huh? What is the vernier scale division value here? 0.9, isn't it? Yeah, that's a small question, isn't it? So what do you do? Least count equals 1 MSD minus 1 VSD, right? So the LC is given 0.1 and 1 MSD is given, that is 1 millimeter. So 1 VSD should equal to what? 0.9, isn't it? It should be 0.9. Easy, right? So the answer is 1, right? Answer is 1. Hands up those who got the correct answers. Good. Huh? I'm sorry, 0.9, sorry. It should be 0.9. Now hands up those who got the correct answer now? Okay, the same, right. Right. Finish? Finish? Now come to the 10th question. When taking a measurement, the scale position of a vernier caliper is as follows. And it says the 10 vernier divisions correspond to 9 millimeter of the main scale. That means the least count is 0.1. Good. The reading will be, now how do you take the reading? There is an equation for that. What is the equation? Length equals MSV plus VSV, and the VSV what?
AC into ES.
Exactly, AC into VSR, right? So we have to apply the values. Now how do you find the MSV? What is MSV? Yeah, main scale value just before the vernier 0. So you have to check the vernier 0. Now this is the vernier scale and this is the vernier 0. And the value just before the vernier 0 is 2 centimeters, isn't it? So either you have to put all the values in centimeters or all the values in millimeters, right? So the answer is in centimeters. Because of that, we will put the values in centimeters, shall we? So it's 2 centimeters plus, now the VSV is LC into VSR. Now we discussed this is 0.1 millimeters. In centimeters that will be 0.01 centimeters, isn't it? That will be 0.01 centimeters multiplied by vernier scale readings. What is vernier scale reading now? Yeah, number of vernier scale lines that are coinciding is the VSR, right? Number of vernier scale lines which are coinciding. Now which line is coinciding here? Not this, not this, not this, not this, maybe this, yeah? So which line is it? 1, 2. Now when you are counting the lines, do you count the 0 line? No, these are the mistakes that you do, right? You don't count the 0 line. You should count the 1, 2, 3 value numbers, right? So that is 1, 2, 3, 4, 5. So the 5th line is aligned, isn't it? So you multiply this by 5. So the final answer is how much? 2.05, not 2.5, right? It's 2.05. 2.05, right? Hands up those who get the correct answer. Nice, nice. By yourself, right? Good, nice. Right. So the 11th question. Which of the following measurements can be obtained with the help of vernier caliper? Now listen carefully, right? Which of the following measurements can be obtained with the help of a vernier caliper? Width of an iron plate. Can you measure it using a vernier caliper? Width of an iron plate. Can you or cannot? Huh? Can, right? Somewhat can. Why not? So width of a iron plate, maybe a small iron plate, you can. Fine, that is okay. Inner diameter of a ball bearing. Can, right? We already discussed it in the tutor as well. Mean diameter of a coin. Can or cannot? Yeah. So mean diameter of a coin is actually can, right? It would be cannot if you are measuring, let's say, the thickness of a copper wire. Can you? No. Why that? Huh? Too thick. The copper wire, huh? Too thin. Okay, that could be one reason. Now, something better than that. Yeah, because the vernier will apply a pressure on it, and the shape of the wire or the diameter of the wire will change while the pressure is applied, isn't it? So you can't measure the metals like copper sheets, copper wires. You can't measure because they cannot be measured with the pressure applied, right? They should be measured without a pressure applied on it. So which can be used for that in that case? Micrometer screw gauge can be used, because in the micrometer screw gauge the pressure isn't applied when you are measuring it. How? How do you measure it using? You use the ratchet. So when you are using the ratchet, when the object is properly pressed, like not properly pressed, properly touched with two of the anvil and spindle, right? When properly contact with the anvil and the spindle, the ratchet will give which sound? Click sound, not the chorus, the click sound, isn't it? So it will give a click sound, click of a sound will give. So when the ratchet gives that click sound, that's only when you can measure the thickness of the given metal, right? So the benefit of using a micrometer screw gauge is what? You can measure something without applying a pressure. So it's useful for the copper wires and sort of the things that the pressure cannot be applied when measuring, right? Right. So for a coin it won't matter, would it? Coin එක press වෙනවද නෑ? Compress වෙන්නේ. Coin won't compress. So three of these can be measured, right? Yeah. All A, B and C. All A, B and C. But if a copper wire or a copper sheet or something very thin metal sheet came to the answer, it cannot be measured with the vernier caliper. You have to know that, right? Nice. Come to the next question, 12. Which of the following instruments do not use vernier scale? Vernier caliper. Vernier caliper is using a vernier scale? It is. Travelling microscope. It is. Micrometer screw gauge. Is it using a vernier scale? No, it's not, right? Triple beam balance. No. So what is the answer? Which is the following instrument do not use the vernier scale? That is C and D. C and D. No answer? Then correct the question. Which of the following instrument uses a vernier scale? Still not? A and B is there, right? Ah, bro, serious. A and B aren't even there. C and D. C and D. No C and D. So here. Oh, we'll put a 6 and say it's C and D, right? So it's C and D, right? C and D. Right, come to the next question. A vernier scale is made by dividing the main scale of 9 mm into 10 equal parts. When the jaws are in contact, the scale position is as follows. Right, now the jaws are in contact, that means you can measure the measurement, and when the jaws are in contact, the scale position is as follows. So how do you take the measurement here now? That's not what the question is asking. Which of the following interval is the error? Right? A vernier scale is made dividing the main scale of 9 mm into 10 equal parts. When the jaws are in contact, the scale position is as follows. Now when the jaws are in contact, what should happen there? The vernier 0 to main scale 0 should be overlapped, right? Otherwise there should be an error, right? Now the vernier 0 and the main scale 0 aren't overlapped, are they? They are not overlapped. So there's an error. Now what could be the error? What is the error? Huh? Yeah, 0 error is there. Yeah, the error type is 0 error, yes. So what is the error? Now what has happened to the vernier? Has it moved backward or has it moved forward? Now which one is the vernier 0? Now this one, A or B? Huh? B is the vernier 0. So has it moved forward or backward? It has moved. Now this is the main scale 0. It's supposed to be here, like not there. It's supposed to be here, isn't it? It's supposed to be there. Now where have it moved? Backward or forward? It has moved forward, isn't it? So forward movement is a positive 0 error. Now we know already a positive 0 error. Now what is the positive 0 error? Huh? Yeah, that's the question. The you tell me the answer in here. What is the error there? Yeah. AB. What is the error there? What do you see the error there? Eh? Yeah, type is positive. I'm asking what is the error in values? A, C, A, D, A, B. Huh? AC. AC is somewhere there. Tell me an answer. What is the error? What is the error? Now I'm going to show you. Just give me a second. There's a vernier. I think, yeah, it's recording. Sorry, Akinder, I think the mic was off. What I said was like, in the origin, the two of the zeros should be aligned. Then if there's an error, now in this case, the vernier zero has moved forward. Now this is an error, right? Now how do you calculate the error? Just, it is the same way taking a usual measurement. How you take the measurement? You are checking how many number of vernier lines are aligned. How many number of vernier lines are aligned now? I think the 9th line is aligned, isn't it? 9 or 8? 8. 8th line is aligned. Now how much of error is there now? 0.8 of error is there. Now that 0.8 of error is the distance travelled by the vernier zero, isn't it? Isn't it? So that error is the distance travelled by the vernier zero. Yes. So here usually the measurement is the distance travelled by the vernier zero, and here it's the error, right? Here it's the error. Usually the distance travelled by the vernier zero is the measurement. When you are measuring something, the distance travelled by the vernier zero is the measurement. Or else you can tell the distance between the main scale zero and the vernier scale zero is the measurement, isn't it? Do you understand that? The distance between the main scale zero and the vernier zero is the measurement. Or the distance travelled by the vernier zero is also the measurement. In this case, the distance travelled is the error, isn't it? The distance travelled by the vernier zero is the error, right? So what is the error here now? What is the error here now? It's AC? It's AB, isn't it? The distance travelled by the vernier zero. Now this is the vernier zero. It was supposed to be here, isn't it? It was supposed to be here. It has travelled from here to here. So the error is what? AB. Hands up those who understood it. Nice. So the error is AB. Error is AB. Got it? Now have these two notes. The distance travelled by the vernier zero is what? Distance travelled by the vernier zero is? It's not always a zero error. The distance travelled by the vernier zero is the measurement. Or the gap between the main scale zero and the vernier scale zero is also the measurement. Now in this case, the distance travelled is the error, because it's supposed to be aligned with the main scale zero. Now it has travelled a bit. So usually the distance travelled is the error here. In this case, it's the error, distance travelled by the vernier zero, right? In this case, the distance travelled by the vernier zero is the error, right? So usually the distance travelled by the vernier zero is the distance or the measurement that we take, right? Do you understand it? Yes? Sure? Good. Right. Understood it? Yes. Had the note? Good. Next question, 14th. What is the value of the above zero error? Now to find the zero error value, you have to know two things. One is the one is the least count. The other one is the number of vernier scales that are aligned. So do you know the least count here? It's given 0.9 because 9 millimeters is equal to 10 parts. So it's 0.1. And which line is aligning? Fourth line, right? So the error is how much? 0.1 into 4, which is 0.4. Not just 0.4 millimeters. In centimeters, it's 0.04, right? So the error we discussed, error is usually a measurement, isn't it? So measurement, we take LC into number of vernier scale lines that has aligned, right? This LC into VS R. Now this is only if it is a positive zero error. But if it is a negative zero error, what would you do? Can you take it the same way if it is a negative zero error? No. What do you do? What would you do? We discussed this. You have to deduct the number of vernier scale lines aligned from what? Huh? Yes. No. From the vernier scale lines. Now this, tell me. Now this is how it's supposed to be, 0 to 0 aligned, right? Now this goes a little behind, right? Now is this a positive zero error or negative zero error? It's a negative zero error. How do you measure it? How do you calculate it? Now the lines are coming back, right? Not forward. We can take the measurements this way if it goes forward, right? Now this has come backwards. So the number of vernier lines are aligned because it came backwards, right? So it hasn't come backward much, isn't it? Then make a balance, which line has aligned? 6 line has aligned, almost. Now it's aligned, yeah? 6 line has aligned, right? So it is 0.6 that has come back. Is it 0.6? No, less than that, right? So how do you take it? You deduct it, you deduct the number of lines from 10. Now you deduct the number of lines from 10. That is the number of vernier scale lines. 10 වලින් deduct කරලා multiplied with the least count, right? If it is a negative zero error, what do you do? You take the number of vernier scales aligned and you deduct it from the total number of vernier scale lines, then only you multiply it by the least count and get the negative zero error, right? So in a negative zero error, how do you do it? Negative zero error, right? Negative zero error, what do? You take the least count and you multiply the deduction of number of vernier scales by the number of vernier scales aligned, right? So it's 10 minus 6 in this case. Do you understand that? Right? If it is a negative zero error, you have to deduct it by 10, right? You have to deduct it by 10 because it's aligning backwards. Backward align වෙනකොට 10 වලින් අඩු කරලා ගන්න ඕන. If it is like a forward movement, it's the usual measurement. If it is coming back, you have to deduct it from the 10. This is the same for what? This is the same for the micrometer screw gauge as well. If it has, you know, rotated backwards, you have to deduct the number of lines aligned from 50 to get the, you know, the error, right? ඒක micrometer screw gauge එකකට එහෙමම තමයි, right? Right. Even you can do that, right? You can take the normal measurement and you have to deduct it from the division value, right? You have to deduct it from the division value. Even that is fine. You can order them මේකේ normal ගත්තොත් කීය දෙන්නේ මේ අපි දැන් මේ measure කරපු එකේ 0.6 නේ. The usual value that it comes 0.6 නේ. Because the 6 line has a line. ඕනනම් 0.6 කියලා අරගෙන 1 mm වලින් මොනවා කරන්න ඕනද? ඩිඩක්ට් කරන්න ඕන. 1 mm වලින් ඩිඩක්ට් කරොත් ඒත් හරි. එතකොට 0.4 එනවා. හරි. නැත්තම් මෙන්න මේ ටෙක්නික් එක මතක තියාගන්න. මොකද්ද? You deduct it from the 10. නේ? You deduct it from the 10. මේකේ පොඩ්ඩක් ඇතුළට හිතුවොත් you will understand the basic theory. Right? I'm just telling you the technique. Technique එක විදියට ගන්නවා නම් අර align වෙන ගාන 10 වලින් deduct කරලා ගන්න. 10 කියන්නේ 10 තමයි vernier scale lines ගන්න. ඉතින් යාගෙන් අඩු කරලා තමයි ගන්න. Right? Right. Break already? We just started. Right? Have a small note on that. If you don't remember it, have a small note on that. If you are if it is a negative zero error, you have to deduct the number of vernier scale lines aligned from the complete number of vernier scale lines. You have to deduct the number of vernier scale lines aligned from the complete number of vernier scale lines to get the negative zero error. Right? පොඩ්ඩක් කුණු වතුර එක. බලන්න මෙතනින් ගිහිල්ලා දකුණට යන්න. කෙලින්ම ගියාම දොරක් තියෙන එකකින් එළිය තියෙනවා. Right? Come to the next question. When measuring the diameter of a sphere with the above caliper, the scale position is as follows. Now the scale isn't given, right? Make a diagram එක නැහැ. ඒක චුට්ටක් තියන්න එක අතයි. මේකට a distance of 9 mm on the main scale of vernier scale coincide with 10 vernier divisions. Here the scale position when the jaws are touched is shown in the diagram A, and diagram B shows the scale position when the depth with the help of a depth probe, right, according to the diagram. Now first one says about the zero error, B says about the measurement, right? Now calculate the zero error. Now tell me if it is a negative zero error or positive zero error. It's a negative zero error. And now you know how to calculate it. Try doing it real fast. Hands up to those who answered it already. Nobody? What is the answer? First, second, third, fourth, fifth. Fourth. Oh, how many? Okay. 3. 0.05. We'll see. Same. 3. Good. Same answer. Okay. Fine, right? What is the answer? 2. 0.04. 0.06. Oh, I මම යුවා. තියෙනවා YouTube එකේ ගිහලා බලන්න playlist එකේ තියෙනවා. මේ ටික බෑ.
දෙපාරක් කියලා ගත්තා.
ඒත් බෑ. අනේ බම්බලා ඉතින් මෙච්චර කලින් දියන්නේ. කමන්න අපි ගොඩ දාමු කොහොම හරි ගොඩ දාමු. නංගි. Thank you. So how do you take the measurement here? Error equals, listen, error equals, now this is a negative zero error. How do you take it? Least count into, that is 0.1 millimeter into what? Vernier scale reading, but the reading you have to take deducting by the number of total vernier scale lines. What is the number aligned? 4. So you have to deduct it from 10. That is the total number of vernier scale lines, right? So 10 minus 4, that is 6. So it's 0.6 millimeters in centimeters, that is 0.06. So the third answer. Yes. 17th question, assuming the depth probe remains correct and zero error is 0, what would be the correct value depth value for depth according to the diagram B? So now the zero error is 0, right? So there is no zero error. You just only have to take the measurement here. So what is the measurement here? What is the formula for the measurement? Length equals MSV plus VSV, and the VSV is LC into VSR, right? Right. So MSCB is what? Now tell me what is the MSC, main scale value? Huh? Tell me in centimeters. Now this is 4. This is, the one next to it is 3.9, right? Isn't it readable? 3.9, and the one next to is 3.8, right? So the main scale value is 3.8 centimeters plus, now we are taking it in the centimeters, right? So the least count should be also in centimeters. So what is the least count? 0.01 centimeters. Which line has a line? Which line has a line? 4. Fourth line has a line. So what is the complete length here now? That will be 3.84, isn't it? 3.84 centimeters. That is second answer, isn't it? Hands up those who got the correct answer. Centimeters වලින්. එයි මේ millimeters centimeters වලින් answer එක දෙයි. Millimeters centimeters කරන්න 10 වලින් divide කරන්න. Yes. Simple things, huh? Understood it? Hands up those who got the correct answer. Right. Hands up those who were there when we are discussing the lesson. Those who were there when we are discussing the lesson. Were you there? You were there. Little bit was there, like in the middle. You there? Who weren't there? Hands up those who weren't there when we are discussing the lesson. You weren't there. You weren't there, right? You weren't there. These people weren't there anyway. So the majority of you were there, right? Rehab wasn't there. Were you? Rehab, yeah, Rehab, right? This guy in the middle, bro, yeah, Rehab, right? Rehab. Okay, you're Muslim. Huh? Christian. That's a Christian. Okay. Rehab. Weren't there, right? Okay. Right. Huh? So any of the Muhammads? No? No Muhammads, right? So it's no. No Fatimas here. No Fatimas back in my entire technology. Yeah. No Fatimas, but that's a pity, right? Yeah. How sad. Sad for you guys, not for me, right? So usually, but some of the Muhammads are here. This is Muhammad. Saad is a Muhammad. Saad isn't here. That's the issue, right? Right. Now come to the 18th question. In a micrometer screw driver, the screw head moves 5 millimeters in 5 revolutions. What is the pitch here? What is the pitch? How do you measure the pitch? How do you measure the pitch? Now, if I give you that question that's in my mind, now not for this, I have a question in my mind to put into the paper. I'm definitely sure none of you will answer this, right? You're still not up to that level. Right? You have to improve a lot, bro. You have to dig into more theory things. You have to think. Your brain have to work much more, right? A questions ටිකක් අමාරුයි. හැබැයි A level එකට එන්නේ නැහැ paper එකට. That's something. හැබැයි if you know up to that level, that means you can answer any of the questions for sure. මොකද ඒ ගානට අර brain එකෙන් වායක මේ process කරගෙන. It's a good level. But I don't see you up to that level yet. I have doubts putting that question to the paper or not. I will see, we'll see. Now tell me what is the pitch? Listen, what is the pitch? What is the pitch? Pronounce the word correctly. Pitch. P-I-T-C-H. What is the pitch? Huh? What is the pitch? Yeah, the gap between two of the screw lines, right? The gap between a groove is a pitch, right? So usually when the circular scale is rotated once, a pitch of a distance is moving forward, isn't it? When you rotate one circle of the screw, that the linear distance moves is equal to the length of a pitch, isn't it? So that is the theory. So now in this question it says the screw head moves 5 millimeters in 5 revolutions. So for 5 revolutions it moves 5 millimeters. So the pitch is the distance per 1 revolution. So how do you find it? Yeah, so 5 millimeters per 5 revolutions. So for 1 revolution it should be how much? 1 millimeter. So the answer is 3. Easy, right? Those questions are easy, very easy. Too easy, isn't it? It's easy. I'm not making it hard. Yeah? For the exam. Oh, that's why I'm thinking twice now. We'll see after finishing the class. Now 19th question. Which of the following is a minimum measurement that can be made with this instrument? Equivalent circular division of N and pitch P. So the least count of a micrometer screw gauge, what is the equation? Pitch over circular scale divisions, right? Pitch over circular scale divisions. The least count is equal to pitch over circular scale divisions, isn't it? Pitch over circular scale divisions. Now here the pitch is how much? Pitch is P and the circular scale divisions are N. So the least count will be P over N. And the answer is 2, right? The answer is 2. Second answer. Now hands up those who at least went through the theory notebook at least once after discussing the lesson. Not many people. Yeah. So you have to do that. When we are discussing the lessons, you have to go refer the theory note back again. Otherwise, you are losing the theory. Now listen. You have a tute. That is the theory note. Right? So now listen. Now the who are joining the fast track 2026, they know how the lessons coming in the future difficult, isn't it? Yeah. So these lessons are somewhat okay. These lessons are somewhat fine. but the lessons that are coming in the future are difficult than this, right? So these things are basics. I'm not telling these are like the very basics, but some of the basic lessons that you can, yeah, easily score, right? Those lessons will be little harder, and you have to improve a lot. You don't come to a A-level class thinking like this will be like the O-level lessons, or this will be like the O-level exams or something, right? It's not. So you have to improve a lot. Little by little you have to improve. Otherwise, like when it comes to the middle, you'll be losing it, right? You'll be losing it. So you have to put so much of brain into this, right? So think of it bit of a responsibility, right? Think of it bit of a responsibility, and try to refer everything when you go back home, right? Try to refer it day to day. That is the best way. Refer it day to day. Like if you had the lesson today, at least try to finish it by tomorrow, right? Go through it, refer it, try to understand it and finish it by the next day. And a good thing you have the recordings, and in the future I won't be giving any. Yeah. Huh? Yeah, you'll have to personally ask the recordings from the institute. I won't be giving any of the recordings. One thing, that you are not studying because you have the recordings. You think that I have the recordings, I don't need to study. If I want, I will go back and with the recording and I will be fine. No, that's not going to happen. Because the fresh memory, when you come to the class, when you understand things, that is a fresh memory. That is something you understood. If you went through it like at least within 2-3 days, you will be really fine. At least within 2-3 days, you will be really fine. You will be really good, right? But more the time it takes, you will be losing all the theory and you will be like, what the hell is he telling? You will be like that. You feel it now. What the hell this guys? Where did we learn this whole theory? So interval, please, so hungry now. This is one of the girls' faces. I don't think the girl sent this. You didn't send this right now. Are you gonna manipulate me now? Not gonna happen. Yeah, see, they have like draw a girl's face. See? Not gonna happen. No. We'll take into like after finishing this part. It goes up to 30 or 34 MCQs. That's all. We'll finish that part and then we will have the interval. Yeah, after finishing one part at least. Right, come to the next. So during 10 revolutions of the head screw, the distance by which the linear scale travel is 5 millimeters. The circular head is divided into 50 equal parts. Which of the following will be the smallest measure? So the least count again is equal to, least count is equal to what? Pitch over, pitch over circular scale divisions, right? So what is pitch? How much is the pitch? The circular scale is divided into 50. The position of the anvil and the spindle of the knife. So if it isn't given, usually it's 0.5. So divide by 50 gives what? 0.01 millimeter, right? 0.01 millimeter. Right. So which one gives the correct, sorry, it's the third or fourth time I said. Now tell, which one gives the correct instrument? Is it the first one? Is it the first one? Usually to the vertical upside, the value increases or decreases? Value increases. So not the first one. Second one, it's fine, isn't it? It's somewhat fine. Third one isn't fine because it has moved a little bit, so it has a zero error, right? Doesn't have a zero error, so this is not. What about this one? It has moved a little bit further, right? 10. Even not this one. So the answer is second one, right? Right. Half millimeter divisions. The circular scale is divided into 50 equal parts. Answer the questions in 22 and 23 using this tool. If the position of the scale when anvil and spindle touch is as follows, when the value of the zero error shown here will be. Now it has given like zero, like half millimeter divisions means 0.5 divisions, no? And the 50 divisions of a scale. Dividing them together gives a 0.01 least count, right? The least count is 0.01. Now they are asking for the zero error here. Now do you see a zero error here? Is there a zero error? Yes. Is it a positive zero error or negative zero error? It's a positive zero error. How do you measure it? How do you measure it? Huh? How do you measure it? It seems so confusing. Huh? Huh? After the? Yeah. After the zero error, yeah. After after the circular scale, it's usually the positive zero error. You have to consider the main scale zero error as well. That we'll see in the next question. Now this is a positive zero error, right? This is a positive zero error. You identify it how? It's supposed to be 0 to 0 aligned, the main scale and the circular scale. But the line which has aligned is more than 0. Now here it's 11, isn't it? Here it's 11. So it has moved, right, forward. So what is the error here? How do you take the error? If it is a positive zero error, it's the same way. How do you take the positive zero error? You multiply the least count by the number of circular scale divisions aligned, right? So the least count is 0.01 millimeters and the number of circular scale lines aligned is 11. So the answer is what? 0.11 millimeters, isn't it? 0.11 millimeters. Understood it? If it is a positive zero error, you take it the usual way. Take it how the usual positive measurement is taken. Measurement එක ගන්න විදිහනේ මොකද්ද? Least count into circular scale reading. That's all. Right? Yeah. Not here. I just gave some of the people's a number. Yeah. Don't change. Right? Finish? Understood it? Right. Come to the next question. What is the zero error if the scale position is as follows and anvil and spindle touch? Right? Now tell me what is the zero error here. Now tell me if it is a positive zero error or a negative zero error. This is a negative zero error. Hands up those who identify this as a negative zero error. Hands up those who identify it as a positive zero error. Hands up those who identified nothing. So many are there. Now, how do you identify this? Is this a positive zero error or a negative zero error? Huh? It's a negative zero error. Why do you say that? The main scale zero error has disappeared, isn't it? Do you see the main scale zero here? No. That means it has come back. Got it? Now in this one, do you see the main scale zero here? Yes. Do you see the main scale 0 here? Why? Main scale 0 disappears only if it came back, isn't it? Understood it? No? The main scale 0 disappears. That's a good thinking. If you understood it, if you thought it, it's a good thinking. The main scale 0 has disappeared. Why? Because it has come back. Good thing. Huh? Now, if you didn't consider that main scale 0, this seems to be a positive 0 error. That is correct. That I agree. True. But the thing, you have to think of the main scale 0 as well. Do you see the main scale 0 here? No. That means it has come back. So, it's a negative 0 error. So, if it is a negative 0 error, how do you calculate it? Same way, LC into least count into අපි කොහොමද වර්නියර් එකෙන් මේක කැල්කියුලේට් කරේ? සබ්ස්ට්‍රැක්ට් කළා. මේකෙත් එහෙමම තමයි. සබ්ස්ට්‍රැක්ට් කරලා කැල්කියුලේට් කරනවා. කොහොමද? LC එක 0.01 LC is 0.01 millimeters and the මේකේ align වෙලා තියෙන්නේ කීයද? 11. ඒක ඩිඩක්ට් කරනවා කාගෙන්ද? 50 වලින්. You have to deduct 11 from the 50. So that gives what? 0.39, isn't it? Yeah. 0.39 millimeters. Understood it? So the answer is actually 3. Answer is actually 3. ඔන්න එයාගේ tricky parts only. පොඩ්ඩක් tricky parts. Good thing if you understood it. Understood it? Right? Come to the next. The diagram shows a part of a screw gauge. The circular scale is divided into 50 equal parts and it moves the linear scale a distance of 1 millimeter in 2 complete revolutions. Now listen, another thing. So if you are still not, thorough with the first lesson, the measurements lesson theories, there's a group B started in SASIP, right? So you can join that class while coming to the current class that you are coming, right? And cover the measurement lessons. So I'll talk with the SASIP management what they can do about it, because mostly if you are coming, you'll have to register and you will sometimes may have to pay at least one of the fraction of an amount sometimes. You'll have to ask it, right? So if you have any the doubts, or if you are not understood well the measurements first lesson, you can come to the physical class there, or the recordings, complete recordings are there. You can go through the recordings and self-learn for yourself. And the best thing that I suggest is you sit as a group and study. That is the best way you improve your knowledge, right? You work as a group, because there are people who understood it, who can manage the questions. So they group together and you discuss it. So the knowledge will come. That is the best thing, because that is how I even studied. I studied with my friends. So when the difficulties are coming, I'm asking one of my friends, and the others, when the difficulties are coming, they are asking myself. So that is how it happens. Some lessons I can do better, some lessons they can do better. So we share the knowledge. Now that is one of the best ways of studying. Study as a group, right? So the knowledge will go from one to one, right? Hands up those who studied group wise recently within the last week. None. Nice. Now for these guys I'm asking from very long days. I can remember you studied like 1 or 2 days as a group. Panadura. You were teaching in the board. Ne? Huh? That was a long time ago, yeah. Can remember. Now start studying likewise. Now you start studying likewise. That is the best way, right? So don't take this ease, right? Now this is not that easy. It's a, I'm not saying it's very hard, but it's a sort of a standard level of a good, the theory are there. So you have to have the proper knowledge, right? So study group wise, you'll be really fine. That is the best thing, right? Right. The diagram shows a part of a screw gauge. The circular scale is divided into 50 equal parts and it moves the linear scale a distance of 1 millimeter in 2 complete revolutions. When spindle and anvil touch, the scale position is as in the figure. Which of the following statement is true? Right? When now it says circular scale is divided into 50 and the linear scale travels a distance of 1 millimeter in 2 complete revolutions. That means how much is the pitch? It travels 1 millimeter in 2 revolutions. So the pitch is the distance traveled when a 1 revolution occurred, right? So that's 0.5 millimeters, right? That is 0.5 millimeters. So the pitch is 0.5 millimeters and it is divided into, the circular scale is divided into 50 divisions. So the least count is how much? 0.5 divided by, or the pitch divided by circular scale division, that is 0.5 divided by 50. So it's again 0.01 millimeter, right? And now we have to consider the statements given. The zero error is 0. Now do you see there is a zero error? There is a zero error, right? How much of a zero error do you see there? Now it has passed the 0.5 mark, isn't it? So after the 0.5 mark, which line has a line? Second line has a line. So is it a positive zero error or a negative zero error? It's a positive zero error, right? So it's 0.5 plus 0.02, right? 0.5 plus 0.02. So it's 0.52 of a error, isn't it? 0.52 of a error, right? The zero error is 0.002 centimeters and should be added to the instrument reading. Is it correct? No. So is the positive zero error, should the error be added or deducted? Should be deducted. Nice. Zero error is 0. Now it's incorrect. The zero error is 0.052 centimeters and must be added to the instrument reading is wrong. Should be deducted. The zero error is 0.52 centimeters and should be subtracted from the reading shown on the instrument is correct, right? Should be subtracted, isn't it? Yeah. So the answer 4 is correct. Hands up those who understood it. මේක අර දීලා තියෙන පොයින්ට් වලින් ඔයා කන්ස්ට්‍රක්ට් කරගෙන එන්න ඕන. ඒ කන්ස්ට්‍රක්ට් කරගෙන එන එකෙත් සිම්පල් පාර්ට් එකක් තමයි මේ. මීට වඩා ඩිෆිකල්ට් කරන්න පුළුවන් මේක. හරි මේක මීට වඩා ඩිෆිකල්ට් කරන්න පුළුවන්. Right. I was thinking to make it difficult in the paper but I won't do it now. I feel not to do it නේ. පව් නේක තමයි. really. You are not පව්. හරිද? 25. The circular scale of a screw gauge consists of 50 divisions. The smallest measurement of the device is 0.01 millimeter. The pitch of the device will be. How do you find it? It's easy. You can mentally say it. So if 50 circular scale divisions are there and least count is 0.01 millimeters, what is the pitch? 0.5. Can mentally solve it, easy. Huh? Because it was there in the previous questions as well. Because pitch over circular scale divisions is equal to least count. So least count is 0.01 millimeter, pitch is 50. Sorry, the circular scale divisions are 50. So the pitch should be 0.5. The measurements taken using the screw arm referred to in problem number 25 above. Right. Yeah. 20. This one. So it's simple. What? So it's given the circular scale of a screw gauge consists of 50 divisions. The smallest measurement of the device is 0.1. We know the smallest measurement of the least count is equal to pitch over circular scale divisions, CSD. This is the formula, right? And the least count is given how much? 0.01 millimeters, isn't it? So they are asking for the pitch. CSD is given how much? 50. We cross multiply it. Pitch equals 0.5 millimeters. Now I took the answer already. How? Because this was there in the previous question, right? If a 50 millimeter of a pitch is divided into 50 circular scale divisions, least count was 0.01, right? It was the common one. Understood it? That was easy, right? Right. Come to the next question. The thickness of the plate will be. Now first one gives the zero error. Second one gives the thickness. So you have to calculate. How do you calculate? So firstly you have to calculate the zero error. Now what is the zero error here? Yeah. You want to go to the show? Yeah, there is one. Bro, there is one, of course. So you go to the corner, turn to the right side, go straight. There's one. Don't pee in the kitchen, it's after the kitchen, not the kitchen. Now close the door. Right? So listen, so how do you take the measurements here? The thickness of the plate will be. So you have to measure the error and take the visible measurement and either deduct or add the error depending on if it is a positive zero error or a negative zero error. Now tell me, if this is a positive zero error or a negative zero error? It's a negative zero error because it has come, yeah. So how much of a negative zero is there? It's negative. You are telling because the zero appears. Doesn't have to like disappear the zero all the time for it to be a negative zero error, right? So it's a negative zero error, right? How much of a negative zero error is there? 0.02, isn't it? Because the least count is 0.01. So how do you measure the error here? The negative zero error is equal to least count 0.01 millimeter into, do you take the number of circular scale divisions aligned? No. You take the deduction of it. 50 minus, how much has aligned? 48. 50 minus 48. So that is 0.02 millimeters. Now this is the error. Next thing, what do you have to do? Take the measurement. Now tell me the measurement. What is the equation there? Length equals MSV plus VSV, and the VSV equal to LC into VSR, right? LC into VSR. Now tell me what is MSV? What is MSV? 1 millimeter, 1.5 millimeter. That is 1.5 millimeter plus least count is 0.1 millimeters. Sorry, 0.01 millimeters. And the CSR is, now this is MS, now this should be CSV, no? This is CSV and this is CSR, circular scale, Vernier mean, circular scale value, circular scale reading. So what is the CSR there? 1 to 2, right? How much is the circular scale? 2, right? That's 2. So how much is the length? 1.52 millimeters. Now is this the correct value? No, you have to consider the error, zero error. So what is the zero error? 0.02. So should you add or deduct it? Yeah, it's a negative zero error, right? So you should add it. So the actual length, right? Actual length equals 1.52 millimeter plus the error, which is 0.02 millimeter. That will be 0.54. The answer is 3. Hands up those who got the correct answer. Only a few people are there. Good. Understood it? Yes. After the 34th question is. But that's only a 10 minutes of interval. Don't go Arpico, Reels or anywhere. You have to stay in the building. Go pee and come, that's all. Nothing else is allowed. You're hungry? There's a pharmacy downstairs. Take a tablet and... Yeah? Right. I didn't mention any of the intervals. Now come to this one. 27. In measuring the diameter of a sphere with a screw without zero error, the scale position is as shown in the figure. And it doesn't have any of the zero errors, right? Without zero error, yes. If the smallest measurement is taken as 0.01 millimeters, what will be the diameter of the sphere? So you have to measure it. So what is the formula back again? Length equals main scale value plus circular scale value, and the circular scale value is least count into circular scale reading. Now tell me, what is the main scale value? How do you take the main scale value? That is the value just before the circular scale line, right? So this is the circular scale line, and the value just before it is what? So this is 0.5, this is 1, this is 1.5, this is 2. So it's 2 millimeters plus least count was given 0.01 millimeter, and the CSR, what is the CSR? 10, 11, 12, right? Right. So the answer is 2.12 millimeters. 2.12 millimeters. That is easy, right? Yeah. Oh, negative.
නෙගටිව් බිඳුව පේනවනේ.
නෑ බිඳුව පේන්නේ නැහැ කියලා නෙගටිව් ගන්න බෑ. එහෙම ගන්න. අරකේ අපි ගත්තේ ගොඩාක් පිටිපස්සට ගිහිල්ලා ඉඳන්නේ 0 එක පේන්නෙම නැති වෙලා කියලා. හැමතිස්සෙම බිඳුව පේන්නේ නැහැ කියලා ගන්න නැහැ නෙගටිව් 0 එකේ. මෙයා පිටිපස්සට ගිහිල්ලා නම් 0 එකෙන් මෙයාගින් අපි මෙෂර් කරන්නේ. එයා 0 එකෙන් පිටිපස්සට ගිහිල්ලා නම් නෙගටිව් 0 එක. In that case it's a negative 0 එක. අපි අරකේ ගත්තේ පොසිටිව් නෙමෙයි කියලා 0 එක පේන්නේ නැති හින්දා. 0 එක පේන්නේ නැහැ කියන්නේ ගොඩාක් පිටිපස්සට ගිහිල්ලා. ඒකයි 48 ද කොහෙද ගිහිල්ලා තිබ්බන්නේ? ඒක පොඩක් ට්‍රිකි එකක්. ඒක ඇල්ල. ඒ ප්‍රශ්නේ විතර. Right. So the answer is 2, right? Answer is 2. 2.12 millimeters, right? Use the diagram below to answer the questions number 28 and 30. Huh? This one? Done? Right, come to the next one. The diagram below to answer question number 28 to 30. In determining the internal diameter of a capillary tube by traveling microscope, the scale position related to the two positions A and B are shown in the diagram. A and B above. In each case, dash is used to make it easier to identify the coincident position. Consider 0.01 centimeter as the smallest measurement of the microscope, right? The scale position relative to position A is shown in the diagram A. Okay, the position A is shown in the diagram A. And the respective reading will be, right? Now can you take the reading here? What is the reading here? Tell me the reading here. Huh? Now this is the A position. This is the B position. After taking two of the value, you have to subtract. Now you just only have to take one position's value. Now what is the reading here? How do you take the reading? This is the vernier, isn't it? This is the main. Now take how many lines are there? Now this should be 5, no? Centimeters 1, 2, 3, 4, 5. Now these are midlines are given as how? What? 0.5. Do you understand that? Those midlines are 0.5 values. Now where do you see the vernier 0 aligned? That is, now this is 2, 2.1, 2.2, 2.3, 1, 2, 3, 2.35, isn't it? Do you see it? 2.35. So the main scale is 2.35 millimeters. Centimeters, right? 2.35 centimeters. Plus the least count is given 0.01. No, 0.001. 0.001 centimeters. And the number which has aligned is what? Tell me the number aligned. Now, how many lines do you see in one division? One division is how many lines? Now, do you take 1, 2, 3 likewise as the numbers given? No, because 1 is how much? 1, 2, 3, 4, 5. So 1 is 10, isn't it? 1 is 10. So 2 is 20. Good. 3 is 30. And 30, which line has a line? 32. So it should be multiplied by 32. Do you understand that? Now calculate the complete value. 2.35 plus 0.032, right? 0.032. So add it to here. That will be 382, right? 382 centimeters, isn't it? Has some those who understood it, right? That is 2.382. This is the answer. Yes. Understood it? Product change kala dunna passe use your brain na. The questions won't be the same way that the theories are. It will be podi differences are there. Podi difference name they will change it. So you have to think a bit, that's all. Now was this hard? No, right? Now hands up those who think this one was hard, this question was hard? No one, right? Can't see the lines in the diagram, no? It can.
No, can, but it's very hard to count.
Yeah, that's all. Yeah, even wearing the specs. A bit hard to, yeah, because the diagram is a little small. Okay, accept that. Right, shall we come to the next question? The scale position relatively to the B position is shown in the diagram B, the respective reading. Now read the B. What is B? Read the B. So it's 2 centimeter, 2.1, 2.2, 2. It's somewhere between 2. That's 2.25, isn't it? Right? 2.25. Yes? 2.25. The main scale is 2.25 centimeters plus 0.001 centimeter into which line has a line? This line, right? This line has a line. So it's 10, 20, 30, 35, 36, 37, 38, 38. So 2.25 plus 0.038. Adding them together, what do you get? 2.288, isn't it? Centimeters. 2.288 centimeters. Right? Yes? So the answer is 4, 2.288 centimeters. Hands up those who got that. Good. Nice. Right? So the next question. Which of the following will be the inner diameter of the rubber tube? So in traveling microscope, how do you take the inner diameter, or how do you take the diameter when two of the measurements are given? Just only subtract it, and you divide it by 2 if you taken two of the measurements, the vertical and the horizontal, to get the average, isn't it? So you just only deduct the 2, right? So what are the two values? 2.382 deduct 2.288. What is the answer? Third one? 0.094. Right. That's not over yet. No. I said like after finishing the measurement. 34 questions are there. I said 34, yes. You can't rewind now. Huh? 34. 46 are there? Are they after the 46? Why? We have like many more questions to go. Okay, the 34 then. I said the 34 now. We have like 20 minutes to go for the interval. Yeah. 31. What is the smallest mass that can be measured? Now these questions are easy, you can do it mentally. What is the smallest mass that can be measured with a triple beam balance? What is the smallest? That is? Huh? How many? You can't measure the milligrams. So what is the least count of the triple beam balance? 0.1 gram. Answer 2. The figure shows a reading for a measurement taken with a vernier caliper. Its correct value is. Now what is the value here? So this is 2.1, 2.2, 2.3 centimeters. 2.3 centimeters plus how many vernier lines are there? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So it's 0.01 centimeters of a least count, isn't it? Because 10 has a line with 9. So which line has a line? It's this, right? 6 or 7? 6 or 7? 6. 7, right? 7th line has a line. So it's 7. So it's 2.37 centimeters. 2.37 centimeters. So that is answer 5. The figure shows the position of the scale when the jaws of a vernier caliper are in contact. Device 0 error should be. Now that figure is missing. Now remind me to give those figures. I will give them. Now come to the 34th question. What is the light year? Now this is one of the common questions. Common knowledge. What is the light year? That is light speed. mc square. That is Einstein's formula, formula for the converting mass into energy. That's a different case. So what is a light year? What is a light year? What? Disney character? Light year? Who? No, Buzz Lightyear. I'm asking what is light year? No, which character is that? I never heard of a Buzz. Ah, bro. No, not that. Yeah. Too much into this. You're watching anime as well, I doubt. I knew. Now listen. So what is a light year? What means a light year? The distance traveled by the light through a year. Right? So a distance, now listen, distance traveled by light within 1 second is how much? What is the speed of light? So fast. Too fast that you can measure. No, it has already measured. How much is it? 3 into 10 to the power 8, right? That is 3 into 10 to the power 8 meters per second, right? Now this is the speed of light, that is per second. If you want to find it per minute, what would you do? You multiply it by 60. You multiply it by 60, you get the distance traveled per minute by the light. If you want it for an hour, you again multiply it by 60. Now this gives you the distance traveled by the light in an hour. If you want it for a day, you multiply this by 24, right? That is per day. Per year, how many days are there? 365. So this is the distance traveled by the light within a year. So the answer is what? 3 into 10 to the power 8 times 365 into 60 into 60 is 3600. That is correct. But 25 also should be there. This one, right? Fifth answer. Fifth answer. Right, the final question before the interval. Right, 35th. The figure shows the position of the scale when the, now so much of the figures are missing. You didn't even tell me. No? You didn't go through this, huh? Should have tell me? Because the figures are missing. So the 36. Alright, now this is trigonometry starting. Yeah. Take a break and come real quick. So the class starts 12 exactly. So don't go any far. Don't go to the Apico, the Keels. Yeah, the bad people are there. Yeah. Can you what? Yeah. Eat where? No, you only have like 15 minutes to go. Anybody have a Apple charger? No? Nobody. Only I have one. Huh? I do have in the car. I have to go to the car. I'll get it and. Ah, you have one. You don't have the dick. You have power bank. Where? Where? Oh, this is Type C, right? So everything will be on the screen. You have any bad things? Ah, he has a power bank. You can ask for the power bank. Oh. "15 minutes, come quickly." Just starting it, huh? Come quickly. 15 minutes to go. Ah, good. When? Monday? Good thing. For how many days? 5 days, so like you're starting with only like 2 days per week in the beginning, isn't it? Come. Did you say that you'll be having the continuous 5 day of a school? Yeah? Usually at the beginning only 2 or 3 days are there because the 25 people are also still there. So you don't have the room. Let's see. Go and see. Yeah, Joseph's are here, right? Yeah.